Good morning, friends. Now we are doing Simplex method in module number 2 of the subject Operation Research. So Simplex method. So the linear programming problems can be solved easily using graphical method that we have already studied. So Simplex method is an approach of solving linear programming problems by hand using the slack variables tables. The iterations will be done many times, and the pivotal variables will be used as the means to find the optimal solution to optimize the given problem, either to maximize the objective function or to minimize the objective function. If the problem statement is on profit, so the objective function to be maximized. If the statement of the problem is on cost incurred in production, or it will be a loss, so the objective function is to be minimized. So the simplex tabular will be used to perform some row operations that we are going to cover when doing numericals in the linear programming model and to check the optimality, whether the obtained solution is optimal or not. So here the idea of the simplex method is to represent a linear programming problem as a system of linear equations and to obtain a certain solution as the optimal solution. So if we take this problem LPP, so the objective function is to be maximized. So maximize P is equal to 5x1 plus 4x2 subjected to some constraints here. Two constraints are given here, and the variables x1 and x2 cannot take a negative values, so they should be greater than or equal to 0. So first we will convert this less than or equal to constraint as equal constraint with the help of the slack variables. So we are introducing slack variable S1 in the first constraint and S2 in the second constraint here, so that by adding something on the left hand side, so we make LHS equal to RHS, because left hand side is less than the right hand side. So something will be added on the left hand side to make it equal to right hand side. Similarly, the second constraint, by adding something here on the left hand side, it will be made equal to the right hand side. So slack, the shortage. So the shortage will be made equal to the right hand side. So we are introducing the slack variables S1 and S2, and less than or equal to were made it as equals in both the equations. So this is the set of equations number 2. The given set of equations is the problem, that is 1. So now we have the objective function, that is P is equal to 5x1 plus 4x2. So taking 5x1 plus 4x2 to the other side of P, so that becomes minus 5x1 minus 4x2 plus P is equal to 0. So now I have 4 variables x1, x2 given in the problem, and s1, s2 slack variables we consider now. So they are greater than or equal to 0. Now, if we try to find the solution using a graphical method, so that will be plotted as the graph. So x1 is taken as x-axis and x2 is taken as y-axis. So now with we have 4x1 plus 2x2. Initially, if we take s1 and s2 as 0, so 4x1 plus 2x2 is equal to 32. Two variables x1, x2, but with one equation, either x1 is 0 to find out x2, or x2 will be made 0 to find out x1. So if x1 is made 0, so it is 2x2 is 32, so x2 will be 16. So 2 into 16 is 32. If x2 is made as 0, it is 4x1 is equal to 32, x1 will be 8. So 8 and 16. So 8 comma 0. So x1 is 8, x2 is 0. So 8 comma 0. So then x1 is 0, x2 is 16. So 8 and 16. So they will be joined. So that is the first constraint. Then the next constraint, taking initially x2 as 0, we have 2x1 plus 3x2 is equal to 24. So 2x1. So that is, if x2 is made 0, it is 2x1 is equal to 24. In that case, x1 is equal to 12. Then 12 here on x-axis. But x2 is made 0. Then if x1 is made 0, then it is 3x2 is equal to 24. So x2 will be 8. So 0 comma 8. So join this 12 on x-axis and 8 on y-axis. So that is the second constraint. So now the given problem is having the constraints less than or equal to. Both the constraints are less than or equal to. So I have to take the feasible region, so below the two lines. So this area is not considered because it is above the first constraint. This part of the area is not considered because it is crossing the other constraint. So this is the highlighted area is satisfying both the constraints. Now take all the corner points here, 0 comma 0, 0 comma 8, 6 comma 4, 8 comma 0. So with these 4 corner points, find out the value of z. So we'll have the 4 set of p values. So so substituting x1 as 0 and x2 as 0. So in the objective function, so my p will be 0. Similarly, substituting x1 and x2 with these 4 points, we will get 3 more values of p. So take the maximum 1 because the objective function is to be maximized. So this is finding the solution to the given problem using graphical method. In the coming sessions, we will see how to solve the given LPP using simplex method. Thank you, friends.